Welcome all. Section 9.2, we're going to get specific when it comes to a hypothesis test. Now we're going to look at what if you have a categorical variable, and specifically we're measuring a proportion. So for this test, we're going to talk about conditions you have to check. You're going to see some familiar friends, how to actually do it, how to interpret something called power and describe what affects the power, and then look at the relationship between type 1 errors, type 2 errors, and the power of a test. So here goes. We already know significance test. You have a null hypothesis, alternative hypothesis. So going back to the free throw guy or girl, they claim they made 80% of their shots. We think they were exaggerating. So the alternative is we think they make less than 80% of their shots. That we take a random sample. They only made 64%. Is that enough evidence to say, you're lying? And that's what we're kind of tasked with doing. So in order to perform this test, just like we saw in Chapter 8 with confidence intervals, 3 conditions have to be met. We have to have a random sample, or the data has to come from a random assignment in an experiment. We're sampling without replacement, so we have to check the 10% condition. Just to reiterate it, it's the sample size is less than 10% of the population size. And your large counts condition. You have to have at least 10 successes and 10 failures. Now, you'll notice symbols. Oh, man, they're different again. NP sub O. This is like the null value, whatever the claimed value is. So this is really confusing. You're going to use the claim value. We're using that as fact until we prove otherwise to see if we have enough evidence. So when I check this, it would be like 50 shots times 0.8. I'm not going to use the sample proportion. So they do that here. So 40, we expect him or her to make 40 shots. We expect him or her to miss 10 shots. They're at least 10. Great. Sampling distribution is going to be approximately normal. Fantastic. All right. Okay. Once we've checked our conditions and we can move forward and do the test, how do we actually do it? Well, this is going to look really similar to a z-score. We take the statistic minus the parameter. So in this case, the sample proportion minus the claim divided by the standard deviation of the statistic. So it's going to look like this. The sample proportion was 64% minus the 80% claim. Now, you'll notice in the denominator, we're using this claimed value. We're not talking standard error like we were in Chapter 8, where we put the sample proportion in place. We have a claim. We're assuming this is true, so we're using the 0.8 and then the complement. Calculating a z-score, doing normal CDF. This was a one-sided test or one-tailed test. So I would just find the area under the curve from negative infinity to that, comma 0, comma 1. And that's going to give me my p-value, which is 0.002. Just like we talked about last section, that's a conditional probability. If the null is true, if this guy or girl makes 80% of his free throws, there's a 0.002 probability that he's going to make 32 or less by chance alone. So we start to think this person is not being truthful. Could we be wrong? Sure. That's type 1 error. All right, back to the 4 steps. I said they'd be back. Here they are. State, plan, do, conclude. The state is going to be a little bit different. You're going to state your hypotheses and your parameters. And then your significance level. So it would be like test P equals the true proportion of free throws made by player. The null hypothesis, P equals 0.8. The alternative hypothesis, P is less than 0.8. Alpha equals 0.05. We're going to use a 5% significance level always unless they tell us otherwise. Plan, that's where you're going to check your conditions. The do step is what I just went through. You're actually going to calculate your z-score using your statistic minus parameter over the standard deviation of the statistic. And then you're going to use your calculator to get your p-value. That's a potato question. Okay. All right. What happens when the data doesn't support the alternative? Then you're going to fail to reject the null, whether the p-value is like 8% or 80%. Okay. So check your understanding. This is the 4-step process. This is the whole shebang. Like, can you do this? So pause the video, run through the 4 steps. We'll obviously formalize it in class, and then I'll go through it in a minute. So in this case, I want to figure out, they say 20% of teens aged 13 and 19 have electronically sent or posted sexually suggestive images of themselves. So that's the claim. So P is the true proportion of teens aged 13 and 19 who have sent or posted these images of themselves. That's the parameter in context. The null hypothesis would be P equals 0.2. The alternative, the counselor worries it's going to be higher. P is greater than 0.2, and our alpha level, they told us, is 0.05. Boom. That's the state step. Plan. I got to think of my conditions. So random. Was it a random sample? Yes. Random sample of 250. Check. 10%. 250 is less than 10% of 2,800 students. Check. I can calculate my standard deviation based off that. Is the shape of the sampling distribution going to be approximately normal? So I need my large counts condition. There's 63 successes out of the 250. 63 said yes, they did. 250 minus 63, I think, is 187. 187 said no. Both those are greater than or equal to 10, so we're good to go. Sampling distribution is approximately normal. That's it for the plan step. Do, I'm going to just show the answer here. So I take my sample results. The 63 divided by the 250, that's where this 0.252 is coming from, minus the claim, divided by the standard deviation, assuming this claim is true. Z-score is 2.06. You do a little normal CDF from that to infinity, 0.01, and you're getting a p-value of 0.0, let's call it 0.02. That's your plan step. The conclude step, no. What I just mentioned was the do step. The conclude step is your p-value is less than alpha equals 0.05, you reject the null. That means we have convincing evidence for the alternative, that the true proportion of teens who send suggestive images is greater than 20%. So that's the 4-step process we're going to follow all the time. So just get comfortable with it. The more you can practice it, the better off you're going to be. What do you do if you have a two-sided test or a two-tailed test? State is going to look a tiny bit different. The alternative will be not equal to. The plan is going to be exactly the same. The do is going to be very similar. The way you calculate your z-score is exactly the same. However, because we don't know if the value increased or decreased, we have to consider the area in both tails. So if I get a z-score of 2.45, in essence, that means I could be 2.45 standard deviations above the mean or larger, or on the opposite end, 2.45 standard deviations below the mean or lower. So how would I calculate the p-value? I would do normal CDF from the 2.45 to infinity, 0, 1. That's going to give me this area under the tail. And I'm going to double the area, 2 times that area, and that will give me my p-value. Because this is perfectly symmetric, so they're going to have equal areas. All right. This is the whole thing, 4-step process. I'm not going to go through this in the video. You can go through this on your own and then show the answer, which I'd encourage you to do. Encourage you to do. Okay, so now we've learned about confidence intervals. We've learned about significance tests. Why do confidence intervals give you more information? Well, the quick, easy answer to that is they give you an interval. So you have a sense of where the parameter is. For a hypothesis test, if you reject the null, so say for the basketball question, we reject the fact that this person's an 80% free throw shooter. Okay, well, what percent free throw shooter are they? We don't really have any more information to go off of, where the confidence interval does give us that interval. So we have a better idea of what the parameter could be. They're just going through here, the confidence interval versus test statistic, calculating those. So one thing that's nice here is you can use your confidence interval to make a decision about the hypothesis test. So if I'm claiming, I don't know what the context was here, say somebody gets 50% of the votes versus somebody does not get 50% of the votes. I can see from my confidence interval, 50% is not included in this interval at all. So I would reject the null and say I have convincing evidence for the alternative because we're 95% certain the parameter is between 52 and 60, almost 8%. So that's how you can get some more information. I wonder if I can make this bigger. Yes. Okay, so in this check of understanding, they want to know why the confidence interval is consistent with, but gives more information than the test. So I would pause the video and try to work through, based on the null and alternative, what decision would you make about the null hypothesis, reject or fail to reject based on the confidence interval. So to answer that question, looking at the confidence interval, I'm trying to see, is 0.75 included in the interval or not? It is in the interval. That means it's a possible or plausible value for the parameter. So I would fail to reject the null hypothesis. I don't have convincing evidence that it's something other than 75%. I don't care if this goes from 30% to 80%. It doesn't matter. 75% is in there. And that's how I'm going to use that to answer that question. All right. So we went through that. All right, power and error of a test. Type 2 error and power, I mean. Power is kind of this abstract concept, and I struggle teaching it each year. Hopefully this year will, well, not hopefully, this year will be the best job that I've done teaching it, but I can't promise you'll be like, yes, I totally understand you. So in essence, you could see what it is. The power of a test against a specific alternative. It's the probability that the test will reject the null when the alternative is true. So you're making the right decision. The alternative is true and you reject the null. So you want the power to be high. Now you'll remember, if you fail to reject the null when the alternative is true, that's called a type 2 error. So these are complements. The probability of making a type 2 error plus the probability of the power is 100%. Either one or the other happen. So, okay. This is what it's saying here. We say the probability of a type 2 error is beta, Greek letter, beta, and 1 minus beta is the probability of the power of the test. You're not going to have to calculate beta. They could tell you that probability and ask you to find what's the probability of the power, just 1 minus, but very unlikely. What affects the power of the test? A lot of things. Okay, here's the summary. If you increase the sample size, that will increase the power. Increasing the sample size makes everything better. So if you're having a bad day, think about, can I increase the sample size somehow? Yes, you can do it. If you can do that, it's going to increase the power. Why? Because you're more likely to make the right decision. If you increase the significance level, alpha, from 5% to 10%, power goes up. We'll talk more about that in class. And if there's a bigger difference between the null and what the alternative actually is, it's bigger. The bigger the difference, the easier it is to detect, is the best way to say it. Let me see if they say it a little bit better. Okay, think about the person who's an 80% free throw shooter. What would be easier to detect, if they were really a 70% free throw shooter or if they were a 60% free throw shooter? Hopefully you're thinking 60. 60 is even further away from 80, so that would make it easier to detect there's a difference. That's what that's saying. The bigger that difference, the higher the power is going to be. And we call that difference the effect size. So let's look at this, check your understanding. I don't really want to do that. Okay, I'm going to skip number 1. Number 2, you don't need the context, so pause the video here and see if you can answer number 2. Okay. In number 2, the significance level was 5%. Now we're increasing it. I increase the significance level, then the power is going to increase as well. It's easier to reject the null, so it's increasing the power. Random sample of 250 instead of 500, so sample size went down. That makes things worse. So power is going to go down because we're not going to have as much information to make the correct decision. Number 3, insist on being able to detect that p equals 0.1 instead of 0.11. Well, if you remember back to the potato question, the null was 0.08. So 11% is further away, 10% is closer. This is going to decrease the power because it's not as big of a difference. So summarizing here, for a significance test for one proportion, you got to check your 3 conditions: random 10%, large counts, ignore the symbols. You're going to calculate a z-score, and then you're going to use that to get your p-value. We talked about power is when you correctly reject the null hypothesis when the alternative is true. It's a good thing. We went through some details with that.